Bryan from magvortex.org here with a quick definition of the unipolar generator. What is a unipolar generator? Well, a unipolar generator is simply a spinning magnet, as this giant neodymium magnet here, rotating, but it has to rotate on its axis of field. So the field in this magnet is all pointed the same direction through the magnet this way. There's no alternating field around the circumference in any way, like a Hallback field or a Hallback array, that has alternating fields in it. And this does not. This has a single large field coming through the magnet along the axis of the rotation and centered on the axis of rotation. It has to be centered on that axis or you will not get the effect. So in this arrangement, the magnet here is actually conductive, which means that the magnet will produce voltage and current inside itself. So the unipolar generator is a one-piece generator, which is a conductive magnet spinning in the presence of its own field, and it's axially aligned on its axis of rotation, and then it's spun. I'm not going to spin it here. I've got to rebuild this power supply, but I just wanted to define unipolar and then separate it from homopolar here. Let's separate it from homopolar, because here in this apparatus I have both. On this side I have a copper disc, and it's got this pattern on it for my optical encoder to read the RPM, but underneath there's a solid copper piece of circuit board, PCB board. The back side of the copper's been removed, so it's just an insulator there up against the magnet. So when this disc spins in the field of this magnet, it does also produce a voltage right across the radius, but the field source, this magnet back here, is fixed. Typically in a homopolar generator, the field source is fixed and the copper disc spins in front of the field. It actually doesn't work the other way around. This is a non-reciprocal event, and this is very important. If you fix the copper disc and you spin the magnet, we can look at the scope over here. I believe I have it on. If you fix the disc and you spin the magnet, you'll see no deflection of the scope. But if you fix the magnet and spin the disc, you'll see deflection of the scope. So that's a very important difference between homopolar and unipolar. I hope it makes sense. Thank you.